This episode of Sci-Fi Roundtable brought to you by Discount Marksmanship Academy. Each of our courses comes with a free red shirt and refurbished ray gun. Also ask about our 2-day Stormtrooper Weekend Workshop. Discount Marksmanship Academy, located adjacent to the Boonta Eve Pod Racing Coliseum.
Hey everyone, it's Jessie with Everyday Science, and today I am joined by my friends Sean Morse-Barry and Merrick Isbick, and we are just going to host a little roundtable sci-fi discussion, and we're today going to be talking about artificial gravity and how it relates to the USS Enterprise. We all met at a party and we were talking, and do you want to explain how this...
So I've often had this hypothetical question I'd like to ask a physicist about the scenes in science fiction movies where a whole breach happens on a ship that has an artificial gravity system, and there's this incredibly fast rushing of air to leave the ship, and it sucks people away. And my theory is that so long as the artificial gravity hasn't been damaged, it shouldn't be that quick of a motion. The people shouldn't be sucked out. The air would dissipate, but it would be a much slower rate. It wouldn't be nearly as dramatic. Because if the gravity on the ship is equal to Earth's gravity, and Earth's gravity is the only thing that keeps our atmosphere in, then so long as that gravity is in place, it should still be doing something to hold the people back. It shouldn't just be the whole of the ship keeping the atmosphere in.
Yeah, that makes sense. And Merrick had some thoughts on this, and
He did have thoughts.
and yeah, do you want to share those thoughts?
Yeah, sure. Basically, when you're talking about artificial gravity and an enclosed environment that is recreating what we have here on Earth with the atmospheric pressure that we have is basically a result of, God knows, what is it, 70,000 feet to the stratosphere of air, of different compounds, largely nitrogen, oxygen, other trace elements. But as you were saying, gravity is the force that holds it all together. Earth is massive. We have an artificial gravity system on the Enterprise. And if there were a hull breach, if the hull breach were large enough, if it literally tore the ship in half horizontally, so it was just flayed, then there would be no rushing of air, because it would be all trying to equalize with the near vacuum of space from everywhere at once. If the hull breach were localized, if it were a relatively small hole, then it would actually rush out. Think about it like this. If you had a rigid balloon that you had filled with pressurized air, and you punctured it, you would hear all that air rushing out through the puncture, and if you had particulates in there floating around, the particulates would be jettisoned out, because you have so much air, but a much greater vacuum for it to try to dissipate into. So the artificial gravity system that's on the Enterprise is a single direction. It's not actually artificial gravity the way that we have it at the space station, that is a rotational artificial gravity. It's a scientifically generated artificial gravity that pulls everything down.
When you when you say on the space station, I mean, you don't mean the ISS.
I do.
Well, we don't have artificial gravity on the ISS.
But we actually can on some control arms if the space station is spinning. They're not actually currently doing that, but that is something that has been tested in different environments and is actually theoretically possible. That the centrifugal gravity, and that's why, like, when you see things that are postulated, that are rings, and people are walking on the outside of the rings because the centrifugal force is basically holding them there.
Yeah, and just for our viewers, so if you've ever seen 2001: A Space Odyssey, you'll see that you'll see these rotating space station ships, and there's a guy in 52, Van Braun or something, I looked this up before, and he conceptualized this centrifugal force, and it's basically, if you've ever been on one of those gravitron things, sorry, I'm like, if you've ever been on one of those gravitron carnival rides, and they put you on the edges and it spins really, really, really fast, and you're basically just like sucked into like the sides in your back, and you try to like put your arm out and it forces you back. That's what the centrifugal force gravity is. And then there's also the linear acceleration gravity. So if we were just like going really, really fast, like if you're in an airplane or a car and you're going really super fast, it kind of pushes you back. And so that's one way. But what you're talking about is a mass loaded gravity on the on the USS Enterprise, right?
Yeah, I'm saying that the Enterprise doesn't have a mass-loaded gravity.
Oh, it doesn't
because
have a mass-loaded gravity.
That would require there to be an incredibly massive entity that rests so far below the Enterprise that it actually has a uniform planar gravity field on the Enterprise. So what is actually being used, or what would have to be used, is something that is beyond really our understanding, that just creates a gravitational field that is just directional from top to bottom of the Enterprise and doesn't really have a single source where most gravity that we have comes from. And what you're talking about with linear acceleration and centrifugal force, that's all acceleration. Like the centrifugal force, when you're turning is actually a form of acceleration, even if you're maintaining speed. When you're on an airplane, while you're accelerating, you have that force, the G-force. Once you're at speed, you don't have it anymore because you are at speed.
Right, and the problem with that is you would use so much fuel that if you had to constantly accelerate, you would just use tons and tons of fuel, and like it wouldn't be sustainable.
Exactly.
But what about, have you heard of this like the dense, like putting a really dense matter down, like for mass? So maybe there's not enough mass.
Well, there's a similar. I don't know if either of you have seen this science fiction show, Andromeda. That's fine. It's a pretty niche show. It's not everyone's cup of tea. I only watched it because my brother made me watch the first season. But that's something where in that show, the whole of that ship is supposed to be so dense. They don't have force fields in that universe. It's just that the whole of the ship is incredibly dense. It's capable of withstanding a nuclear weapon. And I believe there's going to be people on the internet who might correct me if I'm wrong. That is also the source of the artificial gravity in the ship, is that they do that exact thing, where they just have an incredibly dense piece of matter that is causing actual gravity, not artificial gravity.
I wonder where they got it. Mined from a star.
Yeah, like a dying dwarf star or something like that.
Most likely. The nature of gravitational fields, they have something that's, if you're saying the entirety of the hull or the underside of the ship, because if the entirety of the hull is made out of this incredibly dense matter, then we'd be at the center of a gravitational field. We would be floating, like if you were to get to the center of the Earth and it was hollow, you would literally just be suspended because all the gravity leads to that one place. So if you're surrounded by an incredibly dense hull, then you're going to be at the center of the gravitational field.
I believe the center of the ship is the densest part, and then the hull is just also dense enough to withstand. So the hull itself is not creating the gravity. It's obviously putting out a form of gravity.
So we're talking about the Enterprise, the disk, the base of the
No,
disk.
sorry, that's for Andromeda.
Excuse me.
Yeah, that's for the other show. Enterprise has some form of an artificial gravity system in it that I don't think is, I'm sure in some of the expanded universe books or resources online.
It was like a plate or something,
there's
a
plates.
gravity plate.
They briefly touch upon it in the television show. And Enterprise, which is the ship, the precursor ship to the one that Kirk and Spock fly on, they discuss how there are plates lining the floors that create the gravity. They do not discuss how it works because it's a piece of science fiction technology.
Of course.
But back to the example with the extreme vacuum. So there's a constant myth in movies where if, like a bullet hole is punctures the side of an airplane while it's in flight at 30,000 feet, it can create a strong enough rushing force to rip the side of the wall off and suck people out. Now that's been tested and proven to be false. You can have and also just in actual flights there have been.
They've tested this. They've just tested.
Well, not necessarily with a gunshot, but with puncturing holes. There have been planes that have had like holes punctured in the side at 30,000 feet or so, and yes, it does create a rushing. The air does rush out, but it doesn't suck people out. It doesn't cause larger rips to occur, and that's what we're seeing depicted in the Enterprise. And yes, you're right. The air would definitely get sucked out if there was a small localized hole breach. But I don't think it would have that devastating effect of pulling all the people and all the objects in the ship out with it.
But yeah, it's also science fiction, so it's entertainment, so there's that flair for the dramatic. But
Of course.
I don't know, it seems believable to me.
The
Makes sense.
rushing motion.
Yeah.
Well, this isn't just so. In Guardians of the Galaxy, have either you seen the first Guardians of the Galaxy?
I've seen both.
Okay.
And I love them.
So there's the scene in the first Guardians of the Galaxy where Peter Quill leaves his vessel in order to save Gamora, and he takes his helmet off and he puts it on her. So he's exposed to the elements of space for about 20 to 30 seconds before they're both saved.
Yeah.
And people criticize that as the second he takes his helmet off, he would be killed. And James Gunn, the director of the movie and the writer, did a lengthy post in response to that criticism where he says that they've spoken with NASA consultants, and this is just one of those examples where something is depicted in movies often enough that people assume it to be true. So the depiction that the second you're exposed to the vacuum of space, you die, has been shown enough in movies that people have accepted to be true, but scientists speculate that you could last for 20 to 30 seconds.
Actually a slow, painful death.
Yeah, it would be a slower death than instantaneous. Especially if you had exhaled, you wouldn't have your lungs explode on you because you wouldn't have air within your system too.
Interesting anecdote. When I was a kid, I love scuba diving. When I was a kid, I had a thing I liked to do with taking a hose into the pool, and so I'd have one end of the hose disconnected from any source, obviously outside of the pool, and I'd take the other end of the hose and use it as like a long snorkel and try to descend to the bottom of the pool. Now, I would normally hold my breath as I descend, and when I get to the bottom of the pool, I would attempt to exhale and inhale. And the moment that I would open up my airways with the hose in my mouth, all of the air would be immediately sucked out of my lungs, simply due to the difference in pressure.
Right.
And if I hadn't closed my airways, it probably would have actually damaged my alveoli because of the amount of pressure that is literally pulling everything out of the lungs. So, now I'm not going to touch on having your flesh literally try to expand to take up all of the vacuum of space, because that's a little bit ridiculous. But due to the difference in the pressure from the inside of the lungs to the vacuum of space, the moment the trachea is opened, that all of that air would be sucked out so fast that it could very well and very easily do irreparable damage to the lungs. So like you said, not necessarily an instantaneous death, but probably one that is guaranteed. It would be an inevitability, though it might take a little bit of time to die from a lack of oxygen or be internal bleeding.
But he was probably holding his breath, right?
I think the way that the director talked about it is before he takes the helmet off, he exhales so there's no air in his lungs. He removes the helmet, puts it on Gamora, and they weren't out there for that long. The span of the scene, I think, was 25 seconds before they're rescued by the ravaged ship.
We could hold our breath for 25 seconds.
Yeah, you could do without air for that long.
We won't do it now.
Let's not test it.
But if that's happening, if there's a pressure there, I mean, does that relate to if a hole was blown in the USS Enterprise? Could that be like the trachea of the USS Enterprise?
Very much so.
And that's why it rushes out?
Very much so.
Does that make sense to you? Because you're the one that's very skeptical about
it. It makes sense. It's just a question to me of whether or not it would be pulling the objects and people with it.
Now that makes sense.
Because the gravity should still be holding them down. Like, yeah, they're going to feel the wind, but it's not going to be a rushing enough force to rip them from the ship.
That would be interesting to actually try to calculate what the wind speed would be for different size hull breaches given volumes of air within a ship.
Ooh, I have a shitty science explanation.
Okay.
Because we are weightless in space. And once there's no gravity. Oh no, I've already blown a hole in this because I was going to say there's no gravity, and then they're weightless, and then they rush out because they have no weight, and the feathers can get like sucked out more than like a rock could. But yeah, if there is gravity, but maybe there's gravity, and then there's no gravity, and they're weightless, and then they go.
If the gravity's still working, I feel like they should be fine. Yes, if the gravity doesn't work, then of course they'd be sucked out.
Yeah. So I was looking up some real artificial, like the reason for real artificial gravity and why we should try to find it, or why we should be researching it, and looking at like the centrifugal. There's also centripetal force.
There is.
So centrifugal force. So looking at that motion of force, one of the problems that they had said on one of the amazing internet sites I looked at was that the problem is size. So like the size of the ISS, if they were to do that rotating motion, it's actually gonna kind of suck the blood down from your head to your feet. Like unless it's like the size of a football field, if you're trying to use gravity with that rotational force, your head is gonna like be very light. It's gonna rush the blood down. It's gonna feel really disorienting and not super great.
Yeah, from what I understand, the smaller the diameter of the ring, the faster it needs to be spinning in order to create Earth-like gravity.
Yeah.
So I think 2 rotations per minute is the fastest it could go without causing that effect that you're describing. In order for it to be going at 2 rotations per minute, and still have Earth-like gravity, it would have to be like 735 feet across.
And additionally, what makes it
quick math.
actually less...
Big ring, yeah.
What makes it less lucrative, I guess you could say, practical really, is when you start actually spinning something like the space station. Right now, all the focus is on the joints maintaining the atmosphere that's in the space station, all the connections, etc. When you start spinning, you start adding stresses. You start adding stresses to all the joints in directions that they don't normally have stresses. And then you start needing to reinforce all of these joints, and there's so many components that we don't necessarily need to fly to space for the astronomical, no pun intended, costs of flying things to space.
Well, and then the added fuel, too.
Yeah, it's impractical.
I think it's something that we would only really feel the need to solve if we were doing long-distance space missions, because long-term not having gravity would be terrible for you.
Right, you basically, like, your muscles atrophy, and you know, that's one thing. I should finish that thought, though. There's a few things. I wrote these down. Hold on, I'm cheating. Fluid redistribution, muscle atrophying, sickness, eating, the whole eating thing.
Oh, how it's difficult to get food into your stomach?
Well, and not just that, but think about just spices on your food. I mean, all of these microparticles of spices, or
that's
just
true.
like salt and pepper, and then there's also the bathroom thing.
Mm-hmm.
You know, but they do. I did see on the ISS that when you go to the bathroom, there is an airflow thing, and that is actually a question that I had, because if they can do airflow to suck your bathroom stuff down, so it's not like floating of it. Look at that visual. Then why not have airflow
hold us down?
What's
because it's not
I mean, I know it sounds crazy.
It's not isolated. You would have to be in tubes. Like if we're traveling in tubes being pressed down by immense air.
Pneumatic gravity?
Pneumatic gravity. I like it. What about...
It's just a thought.
Okay, it's fine. Brainstorming. What about magnetism? We all wear suits lined with metal, and then the floor of the ship has a magnet pulling us down.
NASA, we are
It
available.
wouldn't do anything for our our ears. We'd still feel uncomfortable.
Well, and that's the problem with the rotational force too. Is if there's windows, I mean, you see all these beautiful pictures and stuff coming back from the ISS and all. I mean,
you mean looking out and seeing things?
Yeah, you can look out. There's the what's the round thing called that they look out of? There's
the holodeck. No, the holodeck. the bridge.
The observation.
Yeah, it's the cupola.
Oh, cupola.
The
Gazoon
cupola.
cupola.
I mean, you wouldn't be able to just float
Francis Ford Coppola.
in the cupola and be like, auroras over space.
Well, I don't know if either of you guys saw. Did you guys see Passengers?
I didn't. I
Not
kind of
yet.
wanted to. Just two pretty people.
That's fine.
I mean.
There was this relates to. They are very pretty people. You're right.
That's why people are watching this.
Exactly.
You know, it's like
Eye
Passengers,
candy.
Everyday Science.
Well, honestly, the poster for that movie really told you exactly what they wanted you to know. Because it's just a picture of Chris Pratt's face and a picture of Jennifer Lawrence's face, and that's it. That's all the
movie.
poster was. And then the title is Passengers in between. Their faces, Passengers.
Yeah.
But that ship, there was a lot of... so it seemed like it had the spinning centrifugal force gravity because the ship has these rings that are spinning on the outside.
Mm-hmm.
But when you're inside the ship with the characters, it feels like the space is too massive to be contained within the rings.
Mm-hmm.
So me and my brother got the interpretation that those rings were just kind of stupidly added by like the design team. Like they didn't know what they're for. They've seen them in other movies and they put them on. But my other brother, who I saw the movie with, I saw it with both my brothers, did think that was what they were going for, was that the whole ship is contained within these rings and we were just off on the scale of the rings. But if that was the case, when you're looking out the windows on the ship, you don't see, the stars aren't moving in proportion. You should be like, you know what I mean? The stars are moving
Right.
with them, whereas if
Right.
you're looking and you're spinning constantly, you should be being exposed to new stars all the time. Like you're in a car or
Unless
something.
if you're on the inside of the ship looking out, it is actually some hologram projection of what
like a
you
fake,
would see
to keep you from getting dizzy.
to keep you from getting dizzy.
Yeah, well, I mean, when you're talking about like using these massive rings that generate the centrifugal force gravity, obviously the floor is going to be the outside.
Yeah.
So you're not looking out from the rings. You're either looking through the ceiling at the other end, the other side of the
center of the
ring,
ship. Mhm.
or you're looking out the sides. And so you actually...
It's true.
Your point is still valid, but it would be less noticeable. You're seeing stars like from
your
this
angle.
position.
Oh, I see what you mean. I see. Yeah.
They would be
it's,
moving on you, but yeah, different
wouldn't
direction than when I was
be like.
interpreting.
So another thing I was thinking about was, so for creating gravity, and we have the centrifugal, and we have the linear, and we have just the mass loaded, and then we have our pneumatic, and our magnetic,
magnetism
all of these
pneumatics.
things. And I guess that's sort of part of like what it is with Earth. I mean, we have a magnetic core. No, okay. Well, I'm trying to like bring it back to Earth. But with bringing it back to Earth, I mean, if you have something as big as the Earth, if you have something as big as us, then you could create a gravity with our mass. And it made me think of the Death Star. And Star Wars, it's more kind of fantasy. They don't talk about, artificial gravity, and they don't explain all that stuff. But, I was thinking about the Death Star, and I'm kind of like all like walking around. And I thought, well, if that's as big as the Earth, I don't know, internet, how big is it?
I believe the Death Star is the size of a moon.
Oh, okay, yeah.
Like specific, which is obviously, that's not helpful. There are probably
Force
moons the size of
Awakens
ours.
Death Star.
Well, that was the Star Killer. I think
The Star Killer.
I think I've looked at the Wikipedia for the Death Star one at some point in my life, and I think it was supposed to be roughly the size of our moon, Earth's moon. So there would be enough gravity to walk around. It'd be the same as walking on the moon, which is I think a sixth of our gravity.
Okay, so Darth Vader would not look as badass.
But
walking
I think
around.
what he's about to jump in here and say is that because you're inside the Death Star, you're not. Whereas when we're on Earth, all the gravity's below us because this is where the gravity's coming from. Whereas when you're inside the Death Star, if you were relying on the mass of the Death Star to create gravity, if you're 10 floors down, you're going to be experiencing a different gravity than if you're 1,000 floors down. Does that make sense?
Yeah, like
It does.
if you're at the level that is basically the North Pole of the Death Star,
Okay.
then your floor is basically aligned with the gravitational force going to the center.
Okay.
But if you're on the center of the Death Star and the center deck of the Death Star, and you're literally on the center point of the center deck of the Death Star,
Okay.
then you're at the center of the gravitational field. You have absolutely no gravity. You're basically floating. If you're all the way at the front of the Death Star, or the back, if you want to consider there being a front or the back, then you would constantly be falling toward the center.
It's not a practical, because you understand how, like, if there's 10,000 floors on the Death Star, and you're at floor 5,000,
Yeah.
you're being pulled just as much by what's above you as what's below you. If you're relying on the mass of the Death Star.
No, I mean, what I literally thought of, well, because I was trying to think about it in relation to the Earth, too, which is probably not the best analogy, but I was thinking about if you're falling towards, like, the core of our Earth, like, if you're in the ocean, like, you're going down towards the core still.
You could conceivably actually make something like the Death Star with, let's just say you were to actually take scoops of like a white dwarf star and put it at the center to just increase the mass.
Right, like that mass, yeah,
Because,
that density.
I mean, the density, and this is obviously theoretical, the density of something like a white dwarf star is the equivalent of putting, I think, like 100 oil tankers into a mayonnaise jar.
Jesus.
It's absolutely
crazy,
insane.
yeah.
So if you were to do something like that, then you could build the Death Star starting at obviously further out from the center like an onion. Have decks that are like layers of an onion, and you'd have elevators going out to what is basically the surface of the Death Star. Realistically, only the outer deck would have viewports, and you'd basically be looking through the ceiling, but that would be perfectly fine because you could have the captain's deck, the deck, is really all that needs to see out, and everything else would be maintenance. And like we were saying, like as you get closer to the center, the gravitational field affects you differently. Not so much. Gravity doesn't really change that drastically on when you're talking about something on a large scale, like something the size of a moon or a planet. Consider the fact that when you're at 35,000 feet in the air in an airplane, you're experiencing the same gravity as James Cameron, Michael Bay for Challenger Deep.
It was James Cameron.
As James Cameron experienced when he was in Challenger Deep at 30-something thousand feet under the ocean. So we have this range of like 60,000, even actually more than 60,000 feet to travel around the Earth's surface. and still be subjected to what feels like the same 1 atmosphere's gravity. So
9.81
There's-
seconds squared acceleration coming down. No.
Yes.
So yeah, I mean, yeah, you could do it. You just have to construct the Death Star very differently, and I apologize to the designers of the Death Star for calling them out.
Well, maybe they did. Maybe that's what. Maybe at the center of the Death Star
Well-
is a dwarf star.
I mean,
And
it's
maybe that's
possible.
Why
maybe
they got the
that's-
star is how he got his name.
Exactly,
I
and that's
think
what the
there's
ventilation shaft
Led to?
That's the flaw.
I was going to say there's a much
because-
bigger flaw in the Death Star than the
But-
gravity.
But Rogue One answered that now.
Rogue
Now we
One-
understand.
True.
Oh shit.
They're coming for us.
We didn't permit with the LA Film Commission, and now we're gonna be busted. Just a thought for next week's episode. If you're in the Enterprise and let's say there's gravity plates, the floor has plates that are creating artificial gravity, and that's how they're all stationary. That's their relative that's the relative like bottom, the down is where the
Right.
plates are. So if you're in the ship and you're flying at weird angles, the people shouldn't notice anything. And the people are always being like thrown around as if their gravity's moving with them, correct, Merrick?
Yes and no. Yes and no.
Okay.
Because when you're on Earth,
Person. Yeah.
and let's just say you're like in a fighter jet,
Okay.
and you're flying at a level, basically, at speed, not accelerating, your gravity is pushing you down. When you start to like do a bank,
Yeah.
then even though gravity is pushing down, the acceleration,
the
because
acceleration
you're
gravity.
accelerating, you get the G-force, the centrifugal G-force. And when you're flying through space, even if gravity is pulling down, when you turn and bank like that, you're still getting, actually, you know what? I just
but he's saying
contradicted
that the
myself.
gravity's
I think
The
sideways.
contradictory is turning with you,
You know, I
relative to
I-
you. It's like as if the Earth was spinning with the fighter pilot.
you actually have a very valid point.
Yes, I win! Woo!
Well, so Sean has won this episode
Twist-
of
twist
Roundtable
ending.
Hypothetical Science. Yeah, cool. Well, thank you guys. We'll wrap this one up, and I hope you guys liked this this episode of this new format discussion thing that we're doing. And we're all going to be back, and we might have other guests and other things. And please let us know. I mean, blow holes in our USS Enterprise of an episode. Blow holes in all of this. Let us know what you think. Let us know what topics you would want us to cover. And yeah, thanks so much for watching, and thank you guys for spurring this whole thing.
Thank you for
and
having
coming
us.
And, yeah.
Really enjoy.
I've been looking for an outsource to argue with people. I don't get in trouble for it. So
Well, this is great.
good.
We'll do it again soon.
Great.
And you guys, you can find these guys on social media.
On Twitter at Sean Mobar, M-O-B-A-R.
Okay.
Oh, and Sean is S-E-A-N. That's S-E-A-N, M-O-B-A-R.
Yeah, it's spelled the right way.
Yeah, it's spelled the right way.
S-E-A-N.
I mean, I suppose you could find me. I'm not active on Twitter
Oh,
at all.
What a hipster.
That's okay.
I actually have a Twitter account simply because I felt like I had to get one.
If you were going to follow him, you could just follow me instead.
Yes, please do. Please follow Sean
you.
at
S-E-A-N, M-O-B-A-R.
Awesome, and I'm at Jessie Science and at Everyday Sci TV. Also subscribe to Everyday Science for more stuff and more musical parodies and Element a Day in May episodes and different sciencey and non-sciencey type stuff. And then, is there anything else you guys want to share about anything that you have or want to point people to, or?
I have a movie coming out at the end of July, beginning of August, in that range. So
Sweet.
It's
Well,
a cave. It's a caveman. It's about the caveman that invented stairs. It's a feature film. It's premiering at Tampa Bay Comic Con at the end of July.
That's awesome.
Yep.
Sweet. I can't
And
wait
you
to see that.
can look at that online. I'm stealing all the promotion. You can look at you can look at that online on Twitter at argstairs.
What is it?
Or at argstairs. A-R-G stairs.
Argstairs.
Argstairs. Yeah, that's the caveman's name. He's like the title character.
Argstairs.
So,
Cool.
yeah.
Cool. Awesome. All right. Well, that's all. Bye.
Bye.
This episode of Sci-Fi Roundtable brought to you by Discount Marksmanship Academy. Each of our courses comes with a free red shirt and refurbished ray gun. Also ask about our 2-day Stormtrooper Weekend Workshop. Discount Marksmanship Academy, located adjacent to the Boonta Eve Pod Racing Coliseum.